Hello friends, today we will learn about welded connection and you will see what are the advantages of welding process or welded connection over the bolted connection. And then you will see what is the welding process itself, and finally in this video you will see what are the different types of weld that we have. So let's get started. So if you remember, in the previous videos we discussed about the bolted connection, and here is an example of a bolted connection. So if you see, in using bolted connection, basically we can connect two members. In this case we have a column and we have a beam, and this can be connected using a bolting arrangement. For example, here I have a bolting arrangement. In this case, wave of this beam is connected to this column. Similarly, wave of this portion of beam is connected to this column. Now one can also think to connect these two portions by making welding. So if someone does welding in this portion as well as in this portion, and then he can connect this two member using a welded connection. For example, this is shown here. So if you have these two members, this one and this one, you can use welding and you can connect these two members. So welding is basically another type of connection that can be used to connect two members. So the question arises, what is the advantage of welded connection over the bolted connection? So let's discuss some of the advantages of welded connection. So one of the major advantages of welded connection, that is, there is no reduction in area. So when you use bolted connection, you make certain holes, and that holes basically reduces the effective area of that section that basically takes the load. So let's illustrate this. So if you see, in this case I have one column and this another column, and these two columns are connected using bolting arrangement. So let's say for that purpose we have to make holes. So there is one hole here and another hole here. Similarly, we have more holes in the web portion and also in the flange portion, and then we can connect these two members. So in case of bolting, we are making hole, that is reducing the effective area. But if you see the welded connection example, in this case these two columns can be connected using a weld, and in that case there is no reduction in area. So this is one advantage of the welded connection. So we can say our structural members are more effective in taking load whenever we have a welded connection, because there is no reduction in area. Another advantage is, if I do welding, I can provide a rigid joint. In case of bolted connection, that is bolted connection, you will always have some chance of rotation or translation. So we can't get up to 100% rigidity in bolted connection. But in case of welded connection, we can achieve a rigid connection because members are not allowed to rotate or even translate. Another advantage is no noise production. So if you remember, in one of the clips we showed earlier that if you do riveting, there are four person and there are lots of noise that is going on. And also in case of bolting process, you see there is a noise, but in case of welding there is very less noise. So this is a noiseless environment whenever do welding. Another advantage we have, that it requires very less space. So working space is less in case of welding. In case of riveting, we say it requires 4 levers and 4 levers, as well as in bolting, you see you require a wrench that has a distance. So you basically, in very small space, you can't do bolting or riveting, but you can do welding in that case. So basically welding process requires less work space in comparison to riveting as well as bolting. and aesthetically also the welding joint looks better than the bolted joint. So generally a bolted joint becomes bulky, and because of this long bolts that is coming out of the surface of the connection, so that's why these bolted joints looks bulky, but welded joints looks very nice in those cases. So a speed of fabrication is faster in case of welded joint, because you can simply have to weld, and that requires very less amount of time. So you can erect a structure in very less amount of time if you provide a large number of welds, lots of welds compared to the bolting or riveting. So these are the major advantages of a welded connection. So let's see what are the disadvantages we have for a welded connection. So one of the major disadvantages of a welded connection, that is brittleness. So welded joints are brittle, and therefore their fatigue strength is less than the membered joint. So when you are connecting two members, their strength are basically greater than the welded joints, because welded joints becomes brittle. So you are not going to achieve the strength till the metal's strength. You are going to achieve the strength of connection till only the point of the welded strength, because of this brittleness, and it fails in fatigue loading. And that's why it is very important to inspect the belts in bridges. In case of bridges, you see there is a fatigue loading, because these cars, bus, trucks are going, and these are example of cyclic loading, and that causes a fatigue loading. So we have to inspect the welded connection in the bridges. Another disadvantage is basically that is additional stresses. So when you do welding process, you have to do heating and cooling, and this also happens uneven. So due to uneven cooling and heating, basically members are distorted, and this causes an additional stress. So basically some kinds of a stress that gets locked whenever we are doing the welding. So this additional stresses also reduces the strength of the weld. And for welding connection, you require a very skilled labor. Basically there are some people who does diploma, and then they are welders, they are called welders. So these people goes, and these people are only allowed to do welding. But for bolting, it's not required so much skill labor. Basically semi skill or unskilled can also do this bolting process, but for welding you require highly skilled labor, and it also requires electricity. And for this reason you can't do welding in the remote areas where you don't have the electricity. So you need a continuous electricity for this welding. Another is no provision for expansion and contraction is kept in the connection. So if you see in bolted connection, you can always extend, you can make some holes, and then you can basically connect members, or you can remove some member if you can open the bolt, and then you can remove some member. So there is a chance of expansion and contraction. But in case of welding, it's very difficult to basically remove one welding. You can do some expansion, but contraction you have to basically break the welding. Even for expansion, this is not as simple as in case of bolting. So this is one disadvantage we have, that is it's very less provision for expansion and contraction that is kept inside the connection. For example, if you have, let's say, this connection, so this is bolted connection, then what you can do is you can remove the bolt, and then you can remove this member, and then you can come with another long member, and then you can basically connect, then basically you have expanded. But this is not possible in case of welding, because in that case you have to remove the welding, and then you have to do another welding. So no provision for expansion in case of welding. So the inspection of welding work is more difficult and costlier than the riveting work. As I said, welding requires skilled labor, and that's why this is costlier, and the inspection is little bit more cumbersome. In this case, you require some non-destructive testing. So if you want to inspect the belts, you have to perform some kinds of NDT tests. So this why this is more costlier than the riveting as well as bolting. So you can see the defect in bolt or in the rivet just by looking through the eyes. But in case of welding, you require some kinds of sensor to judge what are the defects that you have inside this belt. So these are the major advantages and disadvantages of a welding connection over the bolted and or riveted connection. Now let us discuss what is the welding process itself. So welding basically consists of joining two steel sections. So you have two steel component and then you can join by establishing a metallurgical bond between them through the application of pressure or through some kind of fusion. So you have two member, and then if you want to connect these two members, then basically you have to establish some kinds of metallurgical bond between these two, and then you can connect these two through welding. And this bond is generally achieved either by application of pressure or we can achieve by applying fusion. The most commonly used process that is used for fusion, that is arc welding. So this is also a fusion process. So when we do arc welding, then we can join two steel components using welding. So what is this bond? What is this welding bond through fusion? So the bond between metal is produced by reducing the surface to join to a molten state. So what we are doing, so let's say if I have one surface here or one component here, another component, a steel component is here, then by heating, these two members in this region becomes molted. And once it becomes molted, and we also apply some kinds of another material, and all these are in the melted state. And once these are in the melted state, then it goes to cooling, and then finally it solidifies, and this is the welding process. So basically the bond between the metal is produced by reducing the surface to be joined to a molten state and then allowing the molten metal to solidify. So first this metals gets molted and then it gets solidifies, and when molten metal solidifies, the union is completed. So once this molten metal gets solidifies, we have finally a bond between this component and this components are basically gets joined. So now let's see what are the different components of a weld. So if you see, let's say I want to join this plate and this plate, that is two steel component, and that we call as a base metal, the part that has to be welded. And then this portion, that is an electrode. So this is often made up of steel, and sometimes this is coated with flux that forms gas shield when it melts. So this basically you have done in your workshop. So when you do the experiment in the workshop, the welding experiment, probably you have done this. And this electrode is attached to a welding machine and which runs through electricity, and then it's try to basically this material gets melted and it comes and makes deposit. And there is an environment, so there is a gas sealed environment. So this is an inert environment that is provided by gases like CO2 or argon that prevents the oxidation of the molten metal. This region is electric arc region that basically provide high temperature that helps in melting of this plate, and also the electrode. And finally you have some of the deposit that is from the weld metal that is coming from this electrode. So this is the deposit weld metal and that is coming from the electrode. So basically electrode and this metal all gets melted and some deposits are here, and when we cool, all this gets solidify, and this makes an union. So this is the process of welding. So till now you have learned what is the advantage of welding over the bolted connection, and then what is the welding process itself. Now we will discuss different types of weld. So what are the different types of weld we have? So mainly we have four types of weld. One is fillet weld, another is groove weld, then we have slot weld, and finally we have plug weld. So let's discuss one by one. So fillet weld. So let's say in this picture we have one plate and this is another plate, and we want to join these two plates. So basically in this region we can weld. So this is the electrode. So electron can go from this region to this region and we can basically weld. So here we will have some kind of welding, and this welding is called fillet weld. So once I weld this will look like this. So this is an example of fillet weld. So fillet weld itself can have different orientation or different types. For example, we can have one T-joint fillet weld. So this that we have shown earlier, this is the example of one plate is perpendicular to the other plate, and this is an example of T-joint. So because basically this is making a T kind of connection, and that's why this is a T-joint. Now you see in this case this electrode and this surface makes an angle of 45 degree. So these are generally given in the code that how much angle should make from this surface and how much angle we should make from this surface, as well as what is the angle by which this electrode should be inclined in the direction of the welder or away from the welder. So these all specifications are generally given in the welding code. So this is another type of fillet weld, that is lap joint fillet weld. So you have one plate over the another plate, so we have some kind of lap, and that's why this is called lap joint. And then we can connect these two by using some kind of basically welding. If you remember the same lap joint in bolting classes, we said we can make a bolt here and then we can connect. Now the same here, but now we are using welding to join these two plates. In this case this angle is 30 degree. Once again, this kinds of a specification is generally given in code that is related to welding. So if I am making a fillet weld, I can have different orientation also. So this is illustrated here. So if you see, we can have different orientation of a fillet weld. For example, we can have a flat position. So this plate and this plate, that is a T connection, and connected using a welding. So now if you see, this welding is flat, something like this. So this is a flat orientation. So this is a weld portion. So this is a flat orientation. Now similarly in this case you have a horizontal position. So in this case weld is in horizontal position or orientation is horizontal. Similarly in this case you have this building is you have to go in the vertical direction, and that's why this is a vertical position orientation. So third one is vertical, and the fourth one you have overhead position, that is one plate is up and another is on the bottom, and then you have to build this from the bottom, and that is basically an overhead position. So you can have different possible orientation of a fillet weld. So you have seen different types of fillet welds and what are the possible orientation for the fillet welds. Now basically fillet welds are most widely used because of their economy and ease of fabrication and adaptability at the site. So fillet weld is mostly used compared to the other welds. Now the shape, if you see, I just shown the shape is triangular cross section. So if you see, in all cases you have a triangular cross section in case of a fillet weld. Unlike group weld that we will discuss soon, they require less precision in filling up or fitting up. So two sections due to the overlap of the pieces. So in case of fillet weld, you have one piece and you have another piece and you can do some kind of fillet welding. So that's why it does not require very much precision, because you have to simply basically weld in this region. But if you see groove weld, in that case you require less precision in fitting up of the material. So in that case you will see you have to fill the material between this gap, and that's why you require more precision when you are doing a groove weld. So as I said, fillet weld has widely been used in the past and it has various applications. For example, if you see, this can be used to join two angles or one gusset plate and an angle. So we can join this lapped angular plates. So we can provide here in this region fillet weld, and then basically we can join these two. We can also join slotted connection. So in this case, there are some slot that has been made in this plate, and then we can do in this region welding, and then we can connect these two members. So this is an example of slotted connection because we have made some slots. We can also use fillet weld for column to beam connection, and that is basically brackets. So in that case we can weld in this region and this region. We can also use fillet weld for column base plates. So this is the column base plate. So this plate is here and this I-beam is basically vertical example of a column, and then we can build in this portion, in the middle also, and we can basically make a column base plate. And this is particularly useful when we are making a built up section. For this example, we have one section is this one, and this one, and then we can make 4 fillet welds, and then we can join these sections. We can make a built up I section. In this case we have to make this weld and this weld. Similarly, we can basically put an extra plate over this built up section to increase the moment of inertia, and in this case we have to provide a fillet weld here and another fillet weld at this position. So due to its easiness, a fillet weld is applied in the field as well as in the workshop for the welding. So if you want to do this connection or the fillet weld connection, it is easy, and that's why this is adopted in the field as well as in the workshop. So fillet welds are assumed to fail in shear. So this is an important point. So when you have a fillet weld, it generally fails in shear. So what this means, so if you see in this case, let's say I have one plate and another plate, this is connected through weld. Let's apply some force to this plate. So if I apply a force to this plate, basically this bolt, so there is a chance of failure along this plane. So along this plane there is a chance of failure, and this will be a shear failure. So if you see in this case, basically in this region there is a loss of contact, or you can say basically weld has left the contact with the plate and basically failure in that case. So this is a shear failure because this is a failure of shear plane, and we can say fillet welds are assumed to fail in shear. So this is failing along this plane. So this is about the fillet weld. Now let us discuss a little bit more about groove weld. So this is used to connect the structural members that is aligned in the same plane. So you see, groove weld is used whenever we have two structural members, they are aligned in the same plane. So let's say I have one plate here and in another plate here, and these two plates are in the same plane. And then we want to connect or we want to join these two plates using welding, and in that case we have to choose a groove weld. So what we will do, we will provide a base plate in the back and often called as back plate. So once I have this back plate, we can basically fill the material in this region, and that is shown here. So if I fill the weld material in this region, we will have a groove weld. So basically this is called groove weld because we are first making a groove and then we are filling the material. So this is an example of groove weld. So we are running from my belt, or that is electrode, we are moving from this direction to this direction, and we can finally fill this. So basically this is also possibility, we can go from this direction to this direction. There are two kinds of welding orientation. One is called pulling, so we can pull the electrode. Another is called pushing, that is we can push the electrode. We have to see the codes which is more easily allowed, or which is easy to handle, and that is generally allowed by the welders. Similar to fillet weld, we can also have different orientation of a group weld. So what are the possible orientation? So we can have very similar orientation as in the fillet weld. We can have a flat position. So this member and this member are in the same plane, and then we have a groove, and then we fill this using a material, and this is a flat position of group weld. And we can have a group weld in horizontal position. So in this case, material is filled in this region. So this is an example of horizontal. We can similarly have vertical position of group welding, or we can have an overhead position of group welding. Generally overhead position is very difficult to handle and very difficult to weld. So generally group weld has a slope of 30 to 60 degree. So when you have a group weld, so you are connecting this member and this member, and then you are making a groove. So in that case, this groove, that is this angle, is of 30 to 60 degree. So this angle is going between 30 to 60 degree. So now what are the different types of group weld we have? So let's see some of the group welds. So we have a square group weld. So in this case, you have a square kind of shape, and that's why this is a square group weld. You have a single V, so this forms a letter V, and this is a double V of group weld. So this is one V on the top and another V that is open in the bottom side. And this is single bevel, and this is double bevel. So you have one and another, so this is double bevel group weld. Similarly, you can have a single U kind of orientation, you can have a double U kind of orientation, you can also have a J kind of orientation. You see simply the J letter of English alphabet, and simply you will also have a double J, that is in that case 2J, one is upside, another is downside. So these are the different types of group weld that we can have in practical daily life when we are doing the welding process itself. So to ensure full penetration and a sound group weld, basically we provide a backup strip plate that is provided behind the two plates, so that we can have a full penetration of the weld. That is, weld material goes inside this groove, and that is a full penetration, that is from one side to the other side, and that's why we often provide a back plate or backup strip. And in case of single bevel or double bevel or U group welds. So this as an example. So you see, this is a V kind of group weld. So if I want to full penetration, I have to provide a back plate in this case here. So I have plate 1 and this is plate 2, and we want to join using a group weld, I have to provide a back plate. Similarly, if I have a bevel joint or J joint or U joint, and that is in case of group welding, we can provide a basically back plate. So another example here, that is a bevel example. You have one plate and another plate, that is plate 1 and plate 2. If you want to fill material inside this, you have to provide a back plate in this case also. So once I have this back plate, the weld material can go from this portion to this portion easily, and we can have a full penetration and we can have a sound weld, sound group weld in this case. So now we will discuss another two kinds of weld, that is slot and plug welds. So slot and plug welds are very uncommon and not used exclusively in a steel industry. So the reason is, when it becomes often, basically in only few cases it is applied, and when it becomes impossible, that is if not possible to use fillet weld or group weld, then only slot and plug welds are used. So when it becomes impossible to use fillet welds or when the length of the fillet weld is limited, then we can provide slot and plug welds are used to supplement the fillet welds. So this is not the main weld in that case. We are just using this, that is the slot weld and plug weld, as a supplement. So how the slot weld and plug welds looks like, so let's see. So if you see, if I want to connect this plate and this plate, then we can make a hole on the top plate and then we can fill the material, that is the welded material. So this is an example of plug weld. This is called plug because this looks like a plug. We are filling some plug inside this hole. So that's why this is called plug weld. Similarly, I can make a slot in place of plug, then it's called slot weld. So we can fill this material, that is the welding material, in this portion, and this will become, say, slot weld. So generally we do the slot on the top part of the plate. So basically we have a slot in only one plate. One important point, in this hole, that is the plug or slot, that comes only in one plate, not in the both plate. And this is shown here. So if you see, I have one plate here and another plate here. So we have made some holes in the top plate and this hole will be filled, and this is an example of a plug weld. So you see, once I fill using the welding material these holes, so this is an example of plug weld. Similarly, I can have different slot and then we can fill each slot with the welding material, then this will be an example of slot weld. So now we have basically discussed all four kinds of weld, that is fillet weld, groove weld, slot weld and plug weld. Now an important consideration when we are doing welding, and that is usually the weld size closer to the minimum size is selected. What is this? So let's say if I am welding this plate and this plate, then I have to do this welding. So this is the welded portion, or that is the welding material, of course, in this case. Now this distance is defined as weld size. We'll discuss this a little bit more, and generally these two remains equal. So either this dimension or this dimension can be called as weld size, and generally these two dimensions are equal. This means this angle is 45 degree and this angle is 45 degree. So this says, so the important consideration is the weld size closer to minimum size is selected. So let's say when we are designing a weld or when we are doing a weld in practical in the field, we try to keep my size minimum. So this is what, when we have to basically play with the length of the weld and the size of the weld. So this is size. And similarly, in the perpendicular direction, you will have weld length. So if you see, if I have this plate, and then if I joining to this plate, then I have to do weld. And then this is the length of weld. So basically, I can play with my length of weld and size of the weld. So if I take larger length, I can reduce my size of the weld. So in that case, we have to minimize my size of the weld. Even if you're not 100% clear at this point of time, don't worry, the size of the weld and the length of the weld we'll discuss in the next video. For the time being, we are saying we have to take minimum size of the weld that is generally often selected. So let us illustrate this. For example, in this case, if I want to connect this plate and this plate, then I have to take a fillet weld, and this is my size of the fillet weld, and this is my length of the fillet weld. So I can basically reduce my size, that is this length, this dimension, by increasing this dimension. So I have to try to reduce my weld size. Why this is so? So you see, this is the weld. So let's say I have a bigger weld size. I require a bigger weld size. So this weld size is, let's say, 12 mm. So I require a weld size, that is this dimension of 12 mm. And once when I do, in the first run I can maximum make of a 4 mm. Then what we have to do? We have to go thrice. We have to do this belt thrice, and then we can achieve only this belt size. So if you do this in the one run, you will get only 4 mm belt, but you have to get a 12 mm. So in that case, you have to perform 3 runs. So in this case, you see, this is the first run of the belt, and this is the second run of the belt, and this is the third run of the belt. So you are doing basically 3 runs, and you are achieving a belt size of 12 mm. So this causes many defects inside the belts, as well as this is basically cumbersome for the labor also, for the skill labor also, and that's why it is often recommended to have a belt size of a smaller size so that we can increase the length, but the belt size remains smaller. We can minimize by defect, we can minimize the error of the welding process itself. So what we were saying is we require a smaller belt size, that is larger size requires more than one run, and that's why this is not recommended for a welding. So this requires finally, so if you have any belt, either fillet belt, groove belt, it requires chipping and cleaning after the first run to remove the slag. So you have any welding connection and final finish you have to give by cleaning as well as removing the slag material. So in this case, for example, if you have this welding material, then you have to remove this slag, and then finally you have to chip, and then you can get the final belt. In case of if you require a larger belt size, you have to do this process thrice. First run, then you have to remove this slag and chip this material and then clean the surface. Then you can do the second overpass, that you can go to the second run, and then you again remove this slag material, clean the surface, and then you can do this process. So you see, once you have a larger belt size, this chipping and cleaning process has to be done thrice. That is extra burden, and that's why this kind of welding that requires larger belt size is not recommended. So to summarize, in this video we discussed different kinds of belts, what is the welding process itself, and what is the advantage of a welding connection over the bolting connection. In the next video, we will see how we can design a belt using Indian standards, that is IS 800 2007. So we can stop here and we'll see you in the next video. Thank you.